Hello everyone. This lecture video gives examples of trigonometry questions with sine, cosine, and tangent ratio. Before we look at the specific examples, please note that the trigonometry calculation can only apply to the right triangle where one of the angle is 90 degrees. Let's look at this right triangle with a side length of 2 and provided angle is 60 degrees. It is important to choose which angle to use for trigonometry calculation and identify where adjacent side, opposite side, and hypotenuse are with respect to the angle chosen. We are given a 60-degree angle in the right triangle and can say the hypotenuse is the one with the side length of 2 and adjacent side is B. There are two adjacent sides next to the angle we have 60 degrees, and the longest side of the right triangle is always hypotenuse and cannot be chosen as adjacent. The opposite side of the angle 60 is A, and now we are all set to calculate the unknown values using the trigonometric ratio. Do you remember the Sohcahtoa, the magic mnemonic to calculate the trigonometry related question? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent ratio is calculated with opposite over adjacent. If you are a little confused about this, please review the trigonometric basis video before you continue on this video. Sine 60 is opposite over hypotenuse and is A over 2. Sine 60 value is square root of 3 over 2, and which is about 0.8660, but we keep them as a fraction as those decimals are rounded value. Since those fractions have the same denominator value, which is 2, we can just compare the numerator values to find A, which is radical 3. Radical, or rad, is synonym of square root. Or you can do cross multiplication to find what A is, which gives the same answer of rad 3. When you do the cross multiplication, you will see the 2 rad 3 is equals to 2 times A, which is 2A. So the A value is equals to rad 3, which gives the exact same answer. Using the cosine ratio calculation, we can find the value B as cosine 60 is B over 2. And cosine 60 is 1/2, and we can find what B value is either using the cross multiplication, or again, we got the same denominator value, so we can just compare, find the value B as 1. In fact, after we have calculated the value A using the sine ratio, we didn't really have to use the cosine to find the B value. We could instead use the Pythagorean theorem, as this is the right triangle, to find the B value. So A squared plus B squared is equals to C squared, and C is the hypotenuse value, and we can simply substitute it in those calculated A and given C value. That'll give us rad 3 squared plus B squared, which is the unknown one, is equals to C squared, which is 2 squared. So the B squared is equals to 2 squared, which is 4, minus rad 3 squared, that is 3, so minus 3. that is equals to 1. So the b value is equals to plus minus 1, but the length cannot be negative, so we take the positive value, which is 1. Now we can verify the answer using tangent ratio. The tangent is opposite over adjacent, that is a over b. A over b is rad 3 over 1, and tangent 60 is square root of 3. This confirms we have calculated the correct values for a and b. Next example is another right triangle with a given angle of 45 degrees and one side length of rad 3. We need to identify the correct opposite, adjacent, and hypotenuse side with respect to the angle given, which is 45 degrees. The longest side, A, is the hypotenuse, and we have two of the adjacent sides next to the angle that we have. However, the A is the longest side, which we already picked that as a hypotenuse, so the B is the adjacent side. Rad 3 is the opposite side of the angle here, and we can write it as opposite here. First, we can find the hypotenuse A using the sine ratio, which is opposite over hypotenuse. That is, sine 45 is rad 3 over A. Sine 45 is rad 2 over 2, which is equals to rad 3 over A. We can do cross multiplication to find A this time. When we do the cross multiplication, we have rad 2A, that is equals to 2 rad 3. And we can divide the rad 2 to the both sides of the equation, which will give me 2 rad 3 over rad 2. We can rationalize this fraction here by multiplying rad 2 to both numerator and denominator value. That gives me 2 rad 6 over 2, and we can cancel these 2's. Finally, we get the A value of rad 6. We can calculate the B value using the cosine ratio or tangent ratio, or even we can use the Pythagorean theorem. However, let's use the cosine ratio to find what B value is. Cosine 30 is equals to adjacent over hypotenuse. So hypotenuse value that we calculate is rad 6. That is B over rad 6. Cosine 30 is rad 3 over 2. So we can say rad 3 over 2 is B over rad 6. We can cross multiply these two fractions to find rad 3 times rad 6 is 2b. Rad 3 times rad 6 is rad 18, which is 2 rad 3. So 2b is equals to 2 rad 3, and we can divide or cancel these two, and we get b value that is equals to rad 3. We can verify the answer using both Pythagorean theorem or using the tangent ratio, but let's use the Pythagoras theorem again. As this is a right triangle, rad 3 squared plus b squared is equals to the longest side, hypotenuse square, 8 squared, and calculated a and b values are rad 6 and rad 3. So rad 3 square, rad 3 square, that is equals to rad 6 squared. And we get 3 plus 3, that is equals to 6, which is true. And this verifies that we have calculated those values correctly. It is very handy to remember and memorize those trigonometric ratio value of the special angles, which are 30 degree, 45 degree, and 60 degrees. I'm going to upload a video related to those special angles with very handy tricks to memorize those values easily. Thank you very much for watching the video, and good luck on studying.